Okay, so the first rule that you need to know for calculus and taking derivatives is the power rule. Now, this is usually the first one that you are going to learn because in calculus you go straight from taking limits into finding derivatives. And the way that they introduce that is with this formula that you've probably seen. This is just like the very first derivative that you're going to take is that f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all divided by h. So you're probably pretty familiar with this by now. Might have had to do some of these by hand. And then so the power rule is just a simplification of this once you're familiar with it. So let's say that we have f of x is equal to x to some integer n. Then f prime of x is going to be n times x raised to the n minus 1. So what you're doing is essentially pulling this n down in front of the x and then subtracting 1. So for example, if our f of x was x to the 6th, then f prime of x would be 6 times x, because we're just pulling the 6 down, and then you do 6 minus 1 in the numerator to get 5. So that would be the derivative of x to the 6th. Now this rule also applies if you have x raised to a negative number. So if we have f of x is equal to x to the negative 5th, we can just do the exact same steps. So first, f prime of x would be, so you pull out this negative 5, multiply it by x, and then you do negative 5 minus 1. So this is negative 5 times x raised to the negative 6th here. One last thing that's really important is that when I say we're pulling down a number, what we're really doing is multiplying it by the constant that's already in front of the x. So in this example right here, we have x to the 6th. There's a 1 here that we don't write just because it would be redundant to write it. So when you pull the 6 down, you're multiplying 6 by 1, which just gets you 6. But if you had a constant in front of your function already, so if we had f of x is equal to 2 times x cubed, and we wanted the derivative of this, when we pull down that 3, we're multiplying it by the 2. So we do 3 times 2, and then this would be x raised to the 3 minus 1. So then our whole thing would be 6x squared in that case. So yeah, just keep that in mind as well. The next one we have is the sum and difference rules. So these apply basically anytime you have a function that is the sum of two other functions, which sounds more complicated than it is. So let's just say we have f of x is equal to g of x plus h of x. Then the derivative of f is just going to be the derivative of g plus the derivative of h. So that means that f prime of x is equal to g prime of x plus h prime of x. Right, and so let's say that we have f of x is equal to x to the 4th plus x cubed. If we want to find the derivative of f of x, we just need to find the derivative of each of these terms individually. So first we'd find x to the 4th, that would be 4x cubed, which we know from power rule. And then we can just add to that 3x squared, which we also would know from our power rule. And then so the difference rule is pretty much the exact same thing, just with subtraction instead of addition. So here we had f prime of x, or I guess I could rewrite this. So f of x is equal to g of x minus h of x. And so then it follows that f prime of x is equal to g prime of x minus h prime of x. So again, not super complicated, but just something that you want to know so that you don't try and do anything crazy. Okay, so next up we have the constant rule. And this one is also not too difficult to learn, and it's a great one to know because it can make a lot of derivatives and integrals really easy later on. So all this says is that if you want to find the derivative of a function that's multiplied by a constant, so let's say k is our constant here, and then f of x is our function. finding the derivative of this is the same as pulling out this constant and then finding the derivative of our function on its own. So these two forms are equivalent. This one on the left, we can multiply by our constant and then find the derivative. And then on the right, we could just find the derivative and then multiply by our constant afterwards. So here's an example of what that might look like. Let's say that we have 3 times x squared. So in this case, k is going to be 3, and then f of x is going to be x squared. So if we use our power rule, we pull this 2 down and multiply it by 3, so we get 6. And then we'll have x raised to the 2 minus 1, or 6x. And then if we were to do this on the right hand side, we would just start with the derivative of x squared. So we'd have x squared and then 2x, and then we would have pulled out this 3 over here. So then we multiply 3 by 2x and we get 6x. So it's a good rule to know, just because it can make things more simple down the line. Okay, so here's where it starts getting a little bit more complicated. The product rule applies when you want to take the derivative of a function that is the product of two separate functions. So that would look like this. We would have d dx of f of x times g of x. Now, it might be pretty tempting to assume that we could just use the same principle from our sum and difference rules and say that this is equal to f prime of x times g prime of x, but that would actually be incorrect. The power rule is the formula, or excuse me, the product rule is the formula that we have to use in order to correctly evaluate this derivative. And it looks a little something like this. So I'll just rewrite this quickly. So d dx of f of x times g of x is going to look like this. So you're going to take the first function and then multiply it by the derivative of the second function, so that'd be f of x times g prime of x. And then you're going to add the derivative of the first function times the second function on its own. So if we have f of x times g of x, we want to find the derivative of that. It's going to be f of x times g prime of x plus f prime of x times g of x. And if you want like a little sentence to help you remember how to do this, the way I remember this is by thinking first d second plus second d first, where d is just represents like derivative, like take the derivative of that function. So if we apply it to this, f of x is our first, g of x would be our second. So first times d second plus our second, which is g of x, times d first, which is f prime of x. So first d second times second d first. Okay, so let's just try a quick example to drive home what we're talking about. Okay, let me just clean this up. So let's say that we have f of x is equal to sine of x, and then g of x is equal to x to the fourth. And we want to find the derivative of f of x times g of x. Okay, so our function is going to look like this: x to the fourth times sine of x. And then keep in mind that it actually doesn't matter which order that these are in. You could have written sine of x times x to the fourth, or x to the fourth times sine of x. The product rule is going to work the same either way, just as long as you do it correctly. So let's go ahead and apply our product rule. We're going to take, we're going to take our first, which is x to the fourth, and then multiply it by the derivative of our second, which is sine of x. So the derivative of sine of x is just cosine of x. Okay, so that was first d second, and now we do plus second d first. And so that's going to look like this. So our second is sine of x and we're going to multiply that by the derivative of our first, which using the power rule is 4x cubed. So this is x to the fourth times sine of x, first d second, plus second d first. Okay, so this is going to be our final answer, and if you want, you can rewrite this as 4x cubed times sine of x over here. So yeah, simple enough, but can be a little confusing once you're new to it. So do a lot of practice problems with this one. And the definition of our quotient rule is going to be the following. So here we have f of x divided by g of x. It's going to be g of x times f prime of x minus f of x times g prime of x all over g of x squared. Okay, so that looks kind of like a mess. Luckily, I do have a mnemonic for this one, similar to the product rule. So here it's going to be, quotient rule is low, I write this out. So low d high minus high d low all over low squared. So f of x is our high, and then g of x is our low. So we have low times d high minus high d low. And then this is all over low squared, which is g of x. Okay, so let's just try and do a quick practice problem to make sure that we understand how to do this. So let's say we want to find the derivative of 5x squared divided by 4x plus 3. So here, our top function, or a high function, f of x, is going to be 5x squared. And then our low function, or bottom function, is going to be g of x, which is 4x plus 3. Okay, find a little more space here. Okay, so we know we have to use the quotient rule because we have some function, f of x, divided by another function, g of x. And so we're just going to bust out our handy mnemonic, which is low d high minus high d low all over low squared. So let's just go through that step by step. So low d high is going to be 4x plus 3, our low, times the derivative of our top function. And if we use power rule, we get 10x. Okay, that was low d high. And now we subtract high times d low. So this would be 5x squared, our high function, unchanged, times the derivative of our low function, which is just 4. Okay? And then we divide all of that by our low function squared, which is 4x plus 3 squared. Okay? So then if we simplify this out, we are going to get 40x squared plus 30x minus 20x squared over 4x plus 3 squared, which simplifies to 20x squared plus 30x, all divided by 4x plus 3 squared. Okay, so that's it. Those are the 5 rules that you need to know if you're going to differentiate functions efficiently and correctly. And then try and remember those 2 mnemonic devices I gave you for the product and the quotient rules. Those are really, really helpful. If you can remember those, they will definitely do you well.